All right, guys. So we're going to slow down a little bit and start to analyze algebraic equations of lines, but comparing those equations, not so much focused on just one, but two at a time. And so since we talk so much about lines, I think it's appropriate that we start in talking about, so Unit 4, today's topic is parallel and perpendicular. All right, so parallel and perpendicular. Now, most of us probably have the definitions of these memorized over the years, but just to clarify, right, parallel, just like the two L's in the word would indicate, they never intersect. Right? So we know how we could graph two lines, and we should be able to think about what the graph of those two lines would look like. But how do you know algebraically that they have the same, they're parallel? Okay, algebraic. So if you think about y equals 2x plus 1 and y equals 2x minus 7, right? Are they parallel? Okay, well, the answer is yes, right? And why? We have to look at the slope. Okay, the slope of these two lines is exactly the same. So if you were to graph them, they're going to follow the same pattern. Now, they do cross at two different points. Now, this is not a graph of these two lines. This is just a random parallel graph that I've drawn. And you'll notice, right? These two graphs follow the same. So this one goes up 3 over 2, right? And so does this line, up 3 over 2. Okay, so that they are following the same trajectory, and therefore they are never going to intersect. They're going to keep following and staying that same distance apart, no matter where on the graph you were to measure vertically their distance, it's going to be the exact same. Okay, so that's parallel, right? They're never going to intersect. They have different y-intercepts, but the same slope. Okay, and then we can look at the opposite of that, right? Is perpendicular. All right, so what does it mean to be perpendicular? What does that cause for us? Well, perpendicular are lines that intersect at exactly, very important, exactly 90 degrees. Okay, no more, no less. It has to be 90. Has to form that perfect right angle intersection. Okay, and so algebraically, how are we going to recognize these? Okay, in an equation, y equals 2x plus 1, the equation for a perpendicular line would be something like negative 1/2 x minus 7. So we don't know where they intersect at, but what's going to indicate that they are perpendicular are the slopes. Okay, a perpendicular slope is a negative, which we should think of as opposite, not necessarily negative, reciprocal. They call it a negative reciprocal only because it's the opposite, okay? Not because it's a negative number, right? So example, right? 3 would have a perpendicular slope, right? So a slope that is perpendicular would be negative 1/3. Whereas negative 3/2 would have a perpendicular slope of positive 2/3. Okay, so it doesn't mean, right, this is just, right, perpendicular slope. And I guess that would be the more appropriate, right? It looks like a upside down T. Okay. There you go. That means perpendicular, right? So as far as slopes go, it doesn't mean when we say negative reciprocal, that does not mean that it's automatically a negative number. It means it's the opposite sign, and basically you flip it over. So it's an opposite flipped version of the number. All right. And so when we start to look at some of these examples and what you're going to be asked to do in the future is given certain points, identify whether they are perpendicular, parallel, or neither. Okay. Perpendicular, parallel, or neither. And again, we can look at an example of a perpendicular set. Okay, so if we kind of look at these two lines to see that they are perpendicular, well, this one goes, right, from here to here. That is up 3/2. So this one is 3/2. You can see they nicely cross, and it's a very 90-degree angle crossing. So if I was to put the box, right, that's the little 90-degree indicator box, those two cross at 90 degrees. Well, what is the slope? We've got to find a good point, and that looks to be a good one there. And we can go from point to point. So there we have that one. So this one's going to go down 2 and right 3. And so this one is -2/3. And you can see, right, we have negative reciprocals. We have opposite, so they're flipped over, and opposite signs. One has to be a negative slope and one has to be a positive slope for them to be perpendicular, with one exception. Okay, I'm not going to tell you the exception. I want you to think about the exception. There's one exception where we do not have a positive and negative slope, but we do have a perpendicular relationship. Okay, so maybe message me on the side if you think you've got it, and I'll confirm that for you if you do. If not, it's not a big deal. We'll talk about it in another time. All right, but let's look at some examples here. So example number 1. All right, example, number 1. You've got line segment AB formed by -2, 3, and 2, 6. And you've got line segment CD formed by -1, 0, and 3, 3. Okay. So if you have a graph, right, we could maybe guess at whether they are parallel or perpendicular. But if that graph is not very accurate, or it could look like they are parallel and they're really not. Okay, it could be something like a slope of 5/6 and a slope of 7/8. Those two slopes, in all actuality, are very close, very similar. They're going to look like they almost have the same trajectory, but eventually those two are going to meet because they're not the same. Those two lines are traveling a little different. Okay, so the only way to prove that is to actually do the math, okay, to actually find the slope of line segment AB, and that is given 2 points. So using the slope formula, x1, y1, x2, y2. And then we're going to do the same for CD. So x1, y1, x2, y2. Okay. So 6 minus 3 over 2 minus -2. So I've got 3/4. And then I've got on this one, I've got 3 minus 0 over 3 minus -1. So again, we have a 3/4. So those two lines are proven to be parallel. Okay, easy enough. So let's look at one more, and then we'll call it a day for today. So example number 2. let's see. Let's go with line segment AB and line segment CD. Okay. Oops. Let me see. Trying to find a good example so we don't step on our toes here. Parallel perpendicular. There we go. And we'll go with, yeah, that one looks good. Okay, so 0, 2, and 5, 4. And then we'll have 1, 8, and 3, 3. Okay, so same process as before. Let's go ahead and find the slopes, compare the slopes, see what we work out to be. All right, very important we keep the order correct. We don't try to force any numbers to match just because they have a relationship of some sort. So we have 4 minus 2 over 5 minus 0. That's going to be 2 over 5. And then we've got the same thing here on the bottom, x1, y1, x2, y2. And we're going to have 3 minus 8 over 3 minus 1. So 3 minus 8 is negative 5. 3 minus 1 is 2. Notice we have not only a flipped over version, so we have a reciprocal. We also have the opposite sign on each one. So we have an opposite reciprocal relationship. So we can call that one perpendicular. Okay. Now, if it's neither one of those situations, right? If it's not a matching slope and it's not a opposite reciprocal or negative reciprocal, it's simply neither. That means that those two lines are just intersecting at some random angle, and it's okay. That happens. That's called a system of equations, and we're going to get to that in the next unit. But right now, we're really focused on the relationship of parallel versus perpendicular. Okay, so if you have any questions, any problems, any concerns, definitely message me. Let me know what it is I can help you with. If not, be looking for any assignments you need to get completed, and we'll see you next time. Thanks, guys.